This is section 9.6, factoring ax squared plus bx plus c. Here you can see we're dealing with a coefficient before the x squared, so it makes things a little more difficult. The simplest case is when the coefficient of x squared only has two factors. Simple numbers like 2, 3, and 5, where you don't have to fool around with 2, 3, 4 different options. In the first example, we're going to factor when b is negative and c is positive. So in this case, it's 2x squared minus 7x plus 3. We need to find two numbers that multiply together to be 3. Luckily, this is really simple. It's 3 and 1. Both of them have to be negative because when multiplied together, they're a positive 3, but when added together, they're a negative 7. And you might be thinking, 3 and 1 can't possibly add together to be 7. But remember, we're foiling here, and we've got a 2x right here at the beginning. So that's going to change our multiplication when we do it. You have to fool around with the placement of the negative 3 and the negative 1 so that you make sure when you FOIL, in this case 2x times negative 3 and negative 1 times x, you end up with a total of negative 7x. If you had switched those around, you would have ended up with a negative 5 as a center term, and that would have been okay. So that would not have been correct. So you have to make sure that you go back and FOIL it and make sure you come back to your original equation. In example 2, we have 3n squared plus 14n minus 5. The negative 5 tells you that the signs of p and q must be different because when multiplied together, they're a negative 5. Again, the coefficient of the n term is a 3, which is simple. It only has two factors, 3 and 1. So we know in one parenthesis we're going to have 3n, and the other we're going to have n. We need to have 5 and 1 in placement there somewhere in different signs, so that when added together they become a 14. Okay, so you have to fool around with this a little bit. It's a little bit like a puzzle. If we know the 3n is here, and the 1n is here, okay, then you just have to decide where the 5 and 1 are going to go. And you might get it incorrect at first. That's why we use pencil in math. Okay? If the negative 1 goes here in the first parentheses and the 5 in the second, you see that you end up with a 15n and a negative 1. That does bring us to the 14n. Okay? So that is the correct placement of the factors. In example 3, again, we have 3t squared plus 8t plus 4. Luckily, both b and c terms are positive, so we know we have positives in both the factors. 3 only has two factors, 3 and 1. So right away, write your 3t in and your t in. Then break down the factors of 4. You could have 4 and 1 or 2 and 2. But because of the 3 coefficient, you just can't add the factors together to see what equals 8. You have to think of the result when it's multiplied by 3. So think of where these are going to go. Okay? If a 4 goes in here and a 1 in here, okay, that would be 4t plus 3t. That would be 7t, but we need 8t. Okay? So 4 and 1 is incorrect. Try 2 and 2. That would be 2t plus 6t. That is 8t. So the correct factorization here is 3t plus 2 times t plus 2. Sometimes you have an a coefficient that's negative. Whenever you do, you need to remove the negative first. Remove it like we did the greatest common factor, only just take a negative 1 out. You never want to fool with the coefficient, the a coefficient being negative. Always positive. So in this example, we have negative 4x squared plus 12x plus 7. Right away, I factored out a negative 1 to change the problem to negative 1 times 4x squared minus 12x minus 7. Okay? Then you have to find the factors of 7 and 4 and start to consider what combinations you're going to use. Well, the factors of 7 are simple. They're 7 and 1. But for 4, you have a couple different combinations you could be dealing with. 4 and 1 or 2 and 2. You have to somehow get a negative 12 as that middle term. So you know 4 and 7 can't work because that's going to end up with 28 in the high 20s somewhere. So try the 2's paired with the 7 and the 1. This is really trial and error. Okay, unless you're really intuitive, you are not going to see this right away. So fool around with it. If we put 2x in both the parentheses and then a 1 and a negative 7, you'll see that we end up here with a 2x and a negative 14x. So that becomes a negative 12x. And that is the correct answer with the first equation. Example 2, negative 2y squared minus 5y minus 3. Again, as soon as you see that negative before the coefficient, you need to remove it. So we're going to take the negative 1 out, and then we're going to be multiplying by 2y squared plus 5y plus 3. Luckily, the 2 only has 2 factors, right? 2 and 1. The 3 only has 2 factors, 3 and 1. So it's just a matter of the placement of the 2 and the 3. Luckily, they're both going to be positive because when we took that negative 1 out, both of these are now positive. So this is going to make it really easy. We put 2y in the first and y in the second, and it's just deciding where the 3 and the 1 go. In this case, the 3 goes with the 2y because this becomes 3y when you multiply it, and this becomes 2y, and that is the 5 that we were looking for. Now we can take a look at vertical motion with a starting height. Remember in the previous section we were looking at vertical motion, but everything was starting from the ground. We always used an s equal to 0. Well, now that we can factor with coefficients, we can solve these kinds of equations. So let's go back to that equation where the height equals negative 16t squared plus vt plus f. Here's the example. A discus is thrown from an initial height of 6 feet. Because usually a discus thrower throws it from around their shoulder, okay, and they're pretty tall guys. They throw it with an initial velocity of 46 feet per second. We want to know when it hits the ground, okay? So the first thing you're going to do is define all your variables. Well, we remember at the ground, h equals 0. They told us that the initial velocity is 46, and we know the initial height is 6, so v equals 46 and s equals 6. So you're going to plug all those values into the equation. The equation is 0 equals negative 16t squared plus 46t plus 6. Okay, now we have to solve it. The first thing you need to do is remove any common factors. Okay, you especially need to get rid of that negative. But having that 2 in there is going to make things more difficult for factoring. It's only adding an extra number that you don't need. So remove a negative 2 from the entire equation. That gives you negative 2 times the quantity 8t squared minus 23t minus 3. Then think about the factors of 8. We have 8 and 1 and 4 and 2. And the factors of 3 are 3 and 1. You need to play around with this a little bit. Okay? I started out with 8 and 1 and it happened to be correct. You may start the other way and figure out it isn't going to work. Okay? But 8 and 1 does work. It's 8t plus 1 times t minus 3. Because when I FOIL it, again, this is negative 24 and this is positive 1. You know, try to keep this number in mind the whole time you're looking at the factors and think, how can I get close to that number? With the 4 and 2, you wouldn't have gotten anywhere close to 23. Okay? So you knew it probably had to be the 8. And the more you do this, the easier it will come to you. Sometimes you're going to see decimal coefficients in a polynomial equation, in a quadratic equation. We're not dealing with decimals or fractions with factoring. It's just going to make it far too complicated. So if you have decimal coefficients, you want to multiply by a power of 10 first to deal with these coefficients and make them all whole numbers, however you can. So in this example, I have 0.1 x squared plus 0.3 x plus 0.2. I would multiply the whole equation by 10 and end up with x squared plus 3x plus 2. Then I have something I'm familiar with that I can actually factor. So again, we will only factor whole numbers, not fractions or decimals. So if you see fraction or decimals, you know you have to multiply by something to make it whole numbers. And remember, when you multiply an equation the whole way through by the same number, you do not change the equation. So you don't have to worry about the numbers being incorrect.